All right, here we go. Hey, if you haven't subscribed, please do so. Throw a like, let people know what we're doing. Let me know how it's going, how I can make it better. Just give me a thumbs up. Let's see how it's going. All right, this is Systems of Linear Equations, Word Problems, Planting a Tree. Julio and Hannah are each planting a tree to make paper. Julio's tree is 9 feet tall and grows at a rate of 1 foot per year. I'm going to go ahead and highlight that sentence because that gives me a lot of information about Julio's tree. Hannah's tree is 1 foot tall. I'm going to go ahead and highlight that. And grows at a rate of 2 feet per year. All right. After 50 years, that's important information as well. The trees will be cut down to make paper. All right, sounds good. Hey, don't forget there's a free PDF in the description in English and Espanol. All right, to find the dependent and independent variables. All right, so the independent variable, that's time. It's always time. So I'm going to let x equal time in years. And that is my independent variable. The y value is going to be, although I'm tempted to do function notation here, it's going to be the height of the tree in feet, and that is going to be dependent. So the height of the tree depends on how many years it's been growing. Let's write the equation for Julio's tree. All right, I'm going to use function notation. So instead of y, I'm going to use j of x for Julio. Notice Julio's tree started off at 9 feet tall. That's the initial height, and grows at a rate of 1 foot per year. So 1 foot per year plus the initial height. So there is an equation for Julio's tree and how fast it grows. Identify the minimum and maximum of the input values. Input is the independent variable time. So the minimum is 0 years. The maximum they gave us in the word problem. It's 50 years. Now let's write an equation for Hannah. Okay, so Hannah, I'm going to call that h of x. Notice Hannah's tree is 1 foot tall when she planted it, and grows at a rate of 2 feet per year. So there's Hannah's equation. Output values. Okay, so the minimum output value is the initial height of the tree. So the initial height is 1 foot. The maximum value is what you get when you input a 50 for x. So to find the max value, you're going to do 2 times that maximum time. The maximum time is 50 years. So that's 100 plus 1, that's 101. So after 50 years, the tree will be 101 feet tall. All right, now what they want us to do is solve the system using the equal values method. Okay, so how we do that is we take the function rule for Julio and set it equal to the function rule for Hannah. And if I solve that for x, that'll give me the number of years it takes for the trees to get the same height. So I'm going to do that. I'm going to go ahead and subtract 2x from both sides. I like to try to get my x's on the left. 1 minus 2 is negative 1. That goes to 0. Now I'm going to go ahead and subtract 9 from both sides. Get those constants over on the right. Negative 1x equals negative 8. It's a good thing here that my time's going to be positive because time can never, ever, ever be negative in the math class. Minus 1, but we're going to divide by that negative 1. That gives me x equals 8. All right, so now I know that I have an x value of 8. I'm going to find the y value. I'm going to go to Hannah's tree. And I'm going to input an 8 where I see the input value x. 17. So that is what the y value equals. So the point of intersection is 8, 17. Okay, That has meaning in this word problem. So let's find out what that means. Shall we? Okay. Does anyone know what that first number 8 means? Okay, those are good guesses. Yeah, I heard a couple of right answers. What about that output 17? What does that mean? Okay. Let's keep going. We're going to graph these functions. To graph the function, I'm going to actually do two things. I'm going to find a minimum and maximum height and time for Julio and for Hannah. So the minimum is time 0, and Julio is 9 feet tall at time 0. Hannah, there might be 2 ends in Hannah. There is 2 ends in Hannah. Hannah at 0 years was 1 foot tall. At 50 years, well, now Julio is 1 times 50 plus 9, so that's 59 feet tall. After 50 years, Hannah is 101 feet tall. We already figured that out from the front. All right, so these are what I did was I used Julio's equation, j of x equals 1x plus 9, and I let x be 0, and I got out a 9. Then I let x be 50. 1 times 50 is 50 plus 9 is 59. I got out a 59. So that's the minimum and maximum height, minimum and maximum time. Same with Hannah. Hannah is a function. So when I put 0 in for Hannah, for years, I get 1 foot. When I put 50 in for years, 2 times 50 is 100, plus 1 is 101. So after 50 years, it's 101 feet tall. All right, time is here. I'm going to do increments of 5. Boom. And I'll show increments right there. And then we have height. We got to get up to 101, so I'm going to do increments of 10. And there's it. And I'm going to make this 120. Okay, that's a nice coordinate plane. Spans most of the grid. That's fantastic. All right, I'm going to plot the ordered pair 0, 9 right there, and 50, 59. So 0, 9 is just under 10, and 50, 59 is just under 60. Continuous or non-continuous? It's a good question. This is continuous. The trees are not just going to jump in height. They're going to continuously be growing a little bit at a time, a little bit at a time. This model is only good from 0 to 50 years. So I will not go beyond those 2 values. Now let's go ahead and graph Hannah. Hannah has an initial height of 1, and then after 50 years is 101. So 0, 1 is just above 0, and 50, 101 is just above 100. And now where they intersect is going to be interesting, right? Because that's the solution for the point of intersection of these 2 functions. So they should intersect at the same place that we intersected earlier, which was at 817. Okay, so right about there, and there it is right there, and that's pretty good. I mean, right, the x value is about 8, and the y value is about 17. So that's pretty dang good. We like that. We liking that. How many years will it take for Julio and Hannah's trees to be the same height? Well, that's where they intersect, right? So remember the point of intersection was 8, 17. So remember I asked you earlier, what does that first number 8 mean? Well, that's the number of years it will take for the trees to become the same height. So 8 years. What is the height of the tree when they're the same? Well, that's the y value. After 8 years, they'll both be 17 feet tall. So that's the point of intersection. It's when they're exactly the same. when the input and the output are exactly the same. Notice it's the only time that's going to happen. How tall will Julio's tree be after 25 years? Well, here is Julio's function. So I'm going to let x be 25. And when I simplify that, I get 34. So after 25 years, the tree will be 34 feet tall. How many years will it take Hannah's tree to get to be 64 feet tall? Well, here's Hannah right here. So we want to know how many years. Well, that's x. So I'm going to let my output be 64 and solve it for my input. Subtract 1, subtract 1. I'm going to go up here and then divide by 2, and you get 31.5. So about 31 and a half years. And remember, it's continuous. You can have a decimal of an input or output. If Hannah chooses not to cut down her tree until it was 70 years old, how tall will her tree be when she cuts it down? Okay, well, again, we're going to go to Hannah's model. And we want to know, okay, how tall will the tree be after 70 years? So we put that in. Looks like it's going to be 141 feet. And that is that. Woo, Hannah and Julio. All right. Good job, everybody. Stay strong. We're on the last leg here. So get to school, get things going, right? Keep it going strong. All right, be good. See ya.